Hello. In this particular case, we are interested in the calculation of the branch voltages and branch currents for the network shown below using the reduced incidence matrix approach. Now here, whenever we are using reduced incidence matrix approach, it is better to represent all the sources, that is in terms of the current source, and all the impedances in terms of the admittances. The better way, first what I will do, I will convert this voltage source into the current source and we will redraw the same figure. Now if we are redrawing this particular figure, in this case this is one node, this is the second, and this will be the third. In that case, just I am redrawing the figure and just I am converting the given voltage source into the current source. In this particular case, already this first source is the current source itself. I will keep this source as it is. Just I will convert the second voltage source, that is this 10 volt source followed by the 2 ohm into its current source. That's it. This is 10 ampere, this is 1 ohm, here it is 2 ohm, and this is again 2 ohm. And what I will do, I will convert this voltage source into the current source. It will be something like this. Here is this resistance. Just I am making the different arrangement, that's it. And this will be the current source. Is it right? This direction is a positive upward side, that's why it is upward direction, and its resistance is 2 ohm. I will keep this 2 ohm as it is. How much is the value of this current source? V upon R, 10 divided by 2, which is 5 amperes. This is 5 amperes. This is the equivalent figure. Now in this case, for the reduced incidence matrix approach, all the resistances must be mentioned in terms of the, or all the impedances are mentioned in terms of the admittances. That's why first I will redraw the same figure and I will try to represent everything in terms of the admittances. If we are doing that, the first figure will be something like this. Just I am redrawing the same figure. I am redrawing the same figure. Here it is branch having this 1 mho as its admittance. This is 2 ohm. This is 2 ohm, and this 2 ohm is replaced by its admittance 1 upon 2, which is 0.5 mho is the value of this impedance. Just we are converting the impedances into the admittances. Now admittance of this branch will be again, it is 2 mho. Admittance of this particular branch is again, it is 2 mho. Is it right? Now here, whatever this current source we have, I will redraw this current source as it is. I will redraw this current source as it is, which is upward direction, and its magnitude, it is the 10 amperes. This current source is the 10 amperes. At the same time, I will draw the remaining part of the figure, which is as it is. In this case, this is the impedance, which is of the 2 ohm. That impedance will be converted into the admittance, which is 0.5 mho. At the same time, here is the current source, which is this, and this current source is of the same magnitude. Just I am redrawing the same thing. Now in this case, this is the current source, which is of the 5 amperes. Is it right? Now any problem based on the reduced incidence, whenever we have the standard figure, any problem based on this reduced incidence matrix can be solved in 8 steps. I will redraw each step one by one. Now here in this case, what is the step number 1? In this case, step number 1 is draw the oriented graph, or we will draw the oriented graph. I will write here oriented graph. Oriented graph or directed graph. Means first we should in a position to draw the oriented graph or directed graph. We will draw this oriented graph. But before drawing the graph, we should give the names to the nodes. Here in this case, if we have, this is one node, I will call it as node X. This is node X. I will call this node as node Y, and I will call this node as node Z. We are giving the names as X, Y and Z. These are the three nodes. At the same time, we will give the numbers to the branches. This is the branch number 1. Then we have, this is the branch number 2, second branch. This is the branch number 2. Then I will give this name to this branch as a branch number 3. And the next one is the branch number 4. These current sources are replaced by its infinite resistance, that is internal resistance, while drawing the oriented graph. That's why we are considering 1, 2, 3, 4. These are the branches. Now assume any suitable direction of the current. If I am assuming the direction for this first branch, I am assuming its current as a downward. For the second branch, I am assuming its current as a forward. And for this third branch, I am assuming its current as a downward. At the same time, for the last branch, I am assuming its current as a downward, which is the fourth branch. There is no logic while choosing these directions of the current. You can choose any random direction for each branch. Is it right? And based on this, we will draw its graph. Now, while drawing the graph, this is one point. This is the second point. This will be the third point. I will call this node as a node X, this node as a node Y, and the next point is nothing but the node Z. Now connect the respective branches between the respective nodes and give the direction to those branches, which is nothing but we will get the oriented graph. How is the procedure for this graph? Already I have discussed in the previous video. Just here I will repeat the same thing. Between X and Y we have this one more and its direction is downward. That's why it is downward direction. Is it right? This 2 ohm, it is forward. This is forward. This is 0.5 more. I will correct something. Here in this case it is downward, which is 0.5 more, this branch. And again we have another branch between these two, which is again downward. Just I will mention here this value, it is 2 ohm. This should be the 0.5 more. I will correct it. This should be the 0.5 more. This is 0.5 more. Is it right? Now this is one branch, its direction is downward. This is the second branch, its direction is forward. This is third branch, its direction is downward. And this is the fourth branch, its direction is downward. These are the branches and its respective points. And this graph is nothing but the oriented graph or directed graph. Is it right? Now what is the second step? If we know the oriented graph or directed graph, now we will draw its next point, which is nothing but reduced incidence matrix. Is it right? Step number 2, which is reduced incidence matrix. Reduced incidence matrix. Now we will draw its reduced incidence matrix. Already I have discussed in one video how to draw this reduced incidence matrix. Still we will try to understand this philosophy. Now look at here. If we have the oriented graph or directed graph, from this oriented graph or directed graph we will draw its reduced incidence matrix in this particular case. Now look at this figure. We have the oriented graph with us. Now the number of rows in the matrix for the incidence matrix is equal to the number of nodes 1, 2, 3. But in case of the reduced incidence matrix, what we are doing, we are treating one of the node as a reference node and we are deleting that particular row. In this particular case, if we are assuming this point as a ground node, then this node will be the ground node and we are deleting this node, means we are considering only the two nodes, that is node X and node Y in this particular case, and we will draw its matrix. Now look at how will be this reduced incidence matrix if we are planning to draw that particular matrix. Now here in this case, if we are drawing the reduced incidence matrix, this matrix A is equal to, this matrix has only the two rows, that is X and Y, because the Z node we are taking it as a reference node. That's why its entry will be not considered in the reduced incidence matrix. How many branches we have? 1, 2, 3, 4, means there will be the 4 columns. This is column number 1, Here is the column number 2. This will be the column number 3 and it will be the column number 4. Now I will make the entries. What are the rules here? For that particular node, consider all the branches. If that branch is outgoing, entry will be +1. If that branch is incoming or branch current is incoming, then entry will be -1. And if that branch is absent to that particular node, then its entry will be 0. If we are making entries for this node X, what about this branch number 1? It is outgoing. That's why its entry will be +1. What about the branch number 2? This branch number 2 is not connected to this node. That's why its entry will be 0. Branch number 3, it is outgoing. That's why its entry will be +1. And branch number 4 is again outgoing. That's why its entry is also the +1. Means in this particular case, its entry is a +1. For node X, 1, 2, 3, these are the 3 currents which are outgoing. That's why these entries are +1, +1 and +1, so on. If we are drawing the same row or calculating the same row for the node Y, in that particular case 1 is incoming, that's why its entry will be -1. This 2 is outgoing, that's why its entry will be +1. And 3 and 4, branch number 3 and 4 are not connected to this node Y, that's why those entries will be 0. This entry will be 0 and this entry will be 0. In this case, the step 3 is the calculation of branch admittance matrix. Branch admittance matrix. Branch admittance matrix is here. In this case, we will prepare the matrix YB. We will prepare the matrix YB of order B into B. B is the number of branches. Here in this case we have the 4 branches. That's why the order of this matrix will be 4 into 4 or 4 by 4 is the order of this particular matrix. Is it right? In this case, this is the original figure for which we are trying to draw this particular matrix. For the branch number 1, its entry is 1 more. This is 1 more. This is Y11. This is Y12. Y13, Y14, because there is no common between 1 and 2, branch number 1. This is the impedance or admittance of the branch number 1. This is Y11, Y12, Y13, Y14. Remaining entries will be 0. Similarly, for the second branch, this entry will be 0 and this entry is 0.5. That is 0.5 more. Then remaining entries will be 0. For the branch number 3, this is Y31, Y32 and Y33. We are interested in Y33, that is admittance of the third branch. Admittance of the third branch, it is the third branch, its admittance is a 0.5, means this entry will be 0.5 and remaining all entries will be 0. Similarly, we are interested in the calculation of the Y44, which this is Y41, Y42, Y43 and this is Y44 and its admittance it is 0.5 more. Means here this is the preparation of this branch admittance matrix which is YB. And if we know the YB, then we can calculate the remaining values which I will discuss in the step number 4. Now look at how is step number 4, calculation of YN. Calculation of Yn, this matrix Yn. What is this matrix Yn? Using this relation is nothing but this is A into YB into A transpose. This is A transpose. Is it right? This A is the reduced incidence matrix. This YB is the branch admittance matrix and this YT is nothing but the transpose of the reduced incidence matrix. If we are trying to find out this Yn, I will arrange the entries in the proper way, which is equal to. If I am coming to this point, in this case, first I am taking the A. I am taking the A, which is nothing but the reduced incidence matrix. How is the reduced incidence matrix in this particular case? How is that value? I will copy here that A. A is nothing but +1, 0, +1, +1. Means this is 1, 0, this is 1 and 1 is the A. That is first row. Then this is minus 1, this is plus 1, 0 and 0. This is the A, which is nothing but the reduced incidence matrix. This is the reduced incidence matrix. 1 0 1 1 minus 1 plus 1 and 0 0. This is A. Into YB. YB is the branch admittance matrix. How is the branch admittance matrix? That I will show. In this case, this is YB. I am copying here YB. How is the YB? 1, 0, 0 and this is 0. This is 0, it is 0.5. This is 0, this is 0. Here it is 0, this is 0, this is 0.5 and it is 0 again. This value is 0, this value is 0, this is 0 and it is the 0.5. These are the entries of the YB, that is branch admittance matrix. If we know the YB, then we will take this into 8 transpose. What is the 8 transpose? Transpose of this matrix means if this first row will become first column, means this is 1, 0, 1 and 1. This is minus 1, this is plus 1, this is 0 and this is 0 is nothing but A transpose. This is A, this is YB and this value is the A transpose. If we know that, we have to work out this matrix multiplication. This is very same as this Yn is equal to, I will keep this matrix as it is. I will find out the multiplication of the first two matrices. This is 1, 0, this is plus 1, this is plus 1, this is minus 1, this is plus 1, this is 0 and this is 0. And here I will find out the multiplication of this matrix, these two matrices. If we are finding the multiplication of these two matrices, how will be its multiplication? That I will put here. In this particular case, how is the multiplication? This multiplication will be 1 into 1 is the 1 plus 0 plus 0 plus 0. Means that entry is the 1. In this case, this first entry will be 1. How is the second? How is the second entry? In this particular case, the second entry will be, this is 1 into minus 1 is the minus 1, 0, 0, 0. This next entry is, it is minus 1, is this value will be the minus 1. Then second row first column, this 0 into 1 is 0, 0 into 0.5 is 0, this is 0 and this is 0, means that complete entry will be 0, this entry it is 0. Then this row into second column is second row and second column. The 0 into minus 1 is 0, this 1 into 0.5 is a 0.5, this is 0, this is 0. Means in this particular case, this entry will be 0.5. Similarly, if we are taking the multiplication of the third row first column, 0 into 1 is 0, this is 0, this is 1 into 0.5 is a 0.5 and this is again 0, is this entry will be 0.5. The next, this third row and second column, 0, 1 into 0 is 0, then 0 into 1 is 0, then this is 0 and then this is 0, is in this particular case this entry will be 0 again. Then last row first column, this is 1 into 0 is 0, this is 0 into 0 is 0, this 0 into 1 is 0, this is 0.5 into 1 is, it is 0.5, is this is 0.5. And then finally this last row and last column, this 0 into 1 into 0 is 0, this is 0, this is 0 and this entry will be 0. Is in this case this entry will be 0. Means we have the multiplication of these two matrices is nothing but this particular matrix. Then here, now we are in a position to find out the multiplication of the two matrices. In this case, if we are finding the multiplication of these two matrices, here its multiplication will be something like this. This is 1 into 1 is 1 plus 0 plus 0.5 and plus 0.5. Means this is 1 plus 0.5 plus 0.5 means it is a 2. Means its entry will be, this value is a 2. Then here this first row and second column. This 1 into minus 1 is minus 1 this is 0, this is 0, this is 0. Means in this case its entry will be, it is -1. Similarly, this second row, first column, 1 into -1 is a -1. This is 0, this is 0, this is 0. Means this entry will be, it is -1. This value will be -1. And finally, if we are multiplying by this second row and second row and second column, this -1 into -1 is a +1. Then it is 1 into 0.5 is a 0.5. Means total addition is 1.5. Then 0, then 0. Means this total value is 1.5. This value is 1.5. And this matrix is nothing but the matrix Yn. Now, if we know the Yn in the step number 4, then we will use the step number 5, which is nothing but the preparation of the current source matrix, which is Is. Now, here the next step is, that is step number 5. In this step number 5, we will find out the current source matrix. Current source matrix. How are the entries in the current source matrix? That I will discuss here. This is column matrix. This current source matrix is the Is. It is the column matrix. Here this is Is. How are the entries? In this case, if we have the 4 branches, then here it will be Is1 plus, sorry, it is Is2, then it is Is3, and this is Is4. That is source in the first branch, source in the second branch, source in the third branch, and so on, which is equal to. What are the rules? And here, if I am trying to discuss with this particular figure, in this particular case, here this current source is attached to this branch. If both directions are same, then entry will be taken as a plus. Otherwise, entry will be minus that particular magnitude of the current source. In this case, this is upward, this direction is downward. Both are reverse. That's why its entry will be taken as this -10. Means entry for that particular branch number 1 is -10. This is branch number 2. No source is attached to this branch number 2. That's why its entry will be 0. For the branch number 3, again there is no source attached for the branch number 3. That's why its entry will be 0. This is branch number 4, and the source is attached to this branch. Its direction is downward, its direction is upward. In that particular case, we can take that current as -5 amperes. This is -5. Means this is the preparation of the current source matrix, which is the step number 5. If we know the step number 5, then next step is the step number 6, which is the calculation of the node voltages. I will go with the step number 6. Here it is the step number 6. That is calculation of the node potentials. Calculation of node voltages. In our case, this is Vx and Vy. These nodes are Vx and Vy because we are interested in the calculation of the potential at this X node as well as at Y node. These are the X and Y node, and for that case we will use the relation, or we will use the equation. We will use the equation in that case. This is matrix Yn into Vn. What is Yn? Node admittance matrix. This Vn is the node voltages, which is equal to minus, it is matrix A, which is the reduced incidence matrix, into the matrix Is, into the matrix which is Is, that is current source matrix. In this case already we have calculated this Yn. Vn is unknown. We are interested in the calculation of the node potentials. This is minus is a sign, that is A is the reduced incidence matrix, already we know, and here is Is, we already know. Means here in this case matrix Yn is known, A is known, Is is known, only unknown is a Vn, and we can find out the values of those node potentials. First I will start with the Vn. This is Yn. I will start with Yn. Means in this case, if we are writing here the Yn, that is node admittance matrix, I will take that matrix, I will copy that matrix from this particular figure. Already we have calculated that particular value of yn. This is yn. I will copy this. How is the value of this yn? This is 2. Here it is minus 1. This is minus 1 and it is 1.5 is the value of yn. Is it right? This is the value of yn. Now here the next is Vn, node voltages. How many nodes we have? For this particular figure we have the 3 nodes x, y and z. Out of that this z node is taken as a reference node and his potential is assumed to be 0. Means we are interested in the calculation of these two potentials only, that is Vx and Vy. This here in this case I will write this is as a Vx and this potential as Vy, which is nothing but the node potentials, which is Vn. This minus sign as it is. A is the reduced incidence matrix. Here I will write that reduced incidence matrix, which is I will copy from here. This is the reduced incidence matrix. This A is the reduced incidence matrix. I will copy that matrix here. How is the A? This is plus 1, 0, plus 1, plus 1. This is minus 1, plus 1, 0 and 0 is nothing but that matrix Vn. A, reduced incidence matrix. And finally we are interested in this column matrix, which is Is, which is the source matrix. Is it right? Which is I have taken here itself. This value will be minus 10, this will be 0, this will be 0 and here this entry will be minus 5. Those are the entries related to the Is, that is current source matrix. If we know those entries, then we can find out the multiplication of these two matrices. Which is equal to, here I will keep this minus sign as it is, and if we are finding this multiplication and if I am writing here, how will be that? Is it right? This multiplication will be the minus 10, 0, 0 and this minus 5. Its entry will be minus 15. Similarly, in this case, this minus into minus, that is a plus 10, 0, 0 and this is 0, means its entry will be plus 10. If we are multiplying by this minus sign, which is same as, in this case, the entry will be this minus into minus, that is a plus 15 and this minus into 10, that will be the minus 10. Means here, this matrix multiplication will be, here it is plus 15 and this is minus 10. If I am copying this as it is, this is 2, this is minus 1, this is minus 1 and this is 1.5. These values into these multiplications. Here it is Vx and Vy, which is equal to this constant, this value. Is it right? Because already this is multiplication by the sign which I have shown here. In this case we have the two equations and the two unknowns. We can use the calculators and we can find out the value of the potential Vx and we can find out the value of the potential Vy in this particular case. If I am using the calculator in this case, I will shift the calculator to the number mode, that is equation mode. Here it is equation. The number of unknowns 2, I will make the entry, this is 2, then it is minus 1 and its constant is plus 15. This constant is plus 15. Then A2 it is minus 1, the next it is 1.5, the next its value is minus 10. It is minus 10. Here the first value is, or Vx is 6.25. This value is 6.25 volt is the Vx. If we are getting the second value, that is Vy, which is minus 2.5 volt. This is minus 2.5 volt is the value of this another unknown, which is Vy. Now in this case we have calculated the two unknowns. These are nothing but the node potentials. One is the Vx and another unknown is nothing but Vy. Sometimes problem may be this one. Up to this, find out the node potentials Vx and Vy by using the reduced incidence matrix. In that particular case, this will be the solution. But in our case, what is the asked thing? Which is the point number 7, calculation of calculation of branch voltages. Branch voltages. Calculation of the branch voltages. How is the equation? That equation is something like this. This matrix VB, that is branch voltages, which is equal to, in this case it is A transpose. This is A transpose into that Vn, which is nothing but the node potentials. Those are the node potentials. I will start with this VB. How many branches we have in our case? In this figure. How many branches we have? We have the 4 branches. This is branch number 1, branch number 2, branch number 3 and branch number 4. Means here in this case voltages will be V1, the second voltage is V2, third voltage is V3, this next voltage is the V4, which is equal to matrix A. A is nothing but, the matrix A is nothing but the reduced incidence matrix, which is this reduced incidence matrix, which is A transpose of this matrix. In this case, this transpose of this matrix is nothing but 1, 0, plus 1, plus 1, and this value is, it is minus 1, this is plus 1, this is 0, and this particular value is 0. This is the transpose of that particular matrix, that is A transpose. And into this node voltages, that is Vx and Vy. Already we have calculated those values. What are the values? If I am checking those values, here the value of the Vx is 6.25. The value of Vx is 6.25. Means here this value is 6.25 and this value is minus, it is 2.5. Now in this case we know these potentials. Now we can find out the voltage, branch voltages, that is V1, V2, V3 and V4. First I will start with the calculation of the V1. The first node voltage, that is V1. The V1 is equal to this first row, first column, that is 1 into 6.25 plus this minus 1 into minus 2.5. Is it right? That is minus 1 into minus 2.5. Now in this case, this is very same as, this is 6.25 plus this minus of minus, that will be the plus, 1 into 2.5 will be 2.5. And if I am calculating this value, 6.25 plus, it is 2.5. If it is, this is 6.25 plus it is 0.5. This value is this is 6.25 plus it is 2.5. This value is 8.75. Means 8.75 volt is the voltage V1. Similarly, how is the V2? This V2 is equal to the second row, first column, 0 into 6.25. This is 0 into 6.25 plus, what is the second case? 1 into this minus, this is 1 into that minus 2.5. It is minus 2.5. This calculation will be, this is 0 plus it is of minus 2.5. This value is very same as it is minus 2.5 volt is the value of that voltage, which is nothing but the V2. If we are finding the voltage V3, this V3 is equal to, here the third row, first column, this is 1 into 6.25. This is 1 into 6.25 plus 0 into, that is minus 2.5. It is minus 2.5. This value is a minus. In this case, this value is, it is 6.25 plus 0. This value is very same as 6.25 volt is the value of the voltage, which is V3. Finally, if we are calculating the voltage of the fourth branch, that is V4, this is 0 into 6, this row and this column, that is 1 into 6.25. This is 1 into 6.25 plus this is 0 into, it is minus 2.5. In this case, which is equal to, this value is 6.25 plus this 0, and this value will found as it is 6.25. Means in this case, The voltage V1 is this value, that is 8.75 volt. V2 is minus 2.5, V3 is 6.25, and V4 is again, that is 6.25 volt is the value of the voltage, which is V4. That is voltage across the first branch, second branch, third branch, and this is the fourth branch. Now in this case, if I am starting with this point, which is the point number 8, here the calculation of branch currents. And how is the formula for the calculation of the branch current? In this particular case, the calculation of the branch currents can be done by using this relation. What is the relation? Here, in this case, this IB, that is branch current matrix, is equal to, this is YB into, it is VB, that is branch voltages VB plus this IS, that is current source matrix, which is equal to. In this case, how many branches we have? In this case, I am repeatedly saying the same thing. We have 1, 2, 3, 4 branches. That's why, how will be this IB? This IB will be something like this. IB will be I1, this is I2, here is I3, and here is I4, because we have the 4 branches. This is equal to this YB. YB is the branch impedance matrix. That YB is the branch impedance matrix. This is YB, branch impedance matrix. We are already aware of this. This YB. I will copy this YB, branch admittance matrix. 1, 0, 0, 0. Means here its entry will be 1, this is 0, this is 0, this is 0. The next row is 0.5. This is 0, this is 0.5, this is 0, this is 0. Next it is 0, this is 0, next is 0.5, this is 0, and for last it is, this is 0, this is 0, this is 0, and this value is again 0.5. This is the calculation of this YB. This is YB into VB. VB is the branch voltages. Just we have calculated the branch voltages. I will note down those branch voltages. Look at here. These are the branch voltages. If I am putting these values, what is the V1? This V1 is 8.75. Here, if I am correcting here, that V1 is, the first voltage is 8.75. This is 8.75. What is the second voltage? In that case, the second voltage is minus 2.5. Means this is minus, it is 2.5. How much is the third voltage? 6.25. This is 6.25. And how much is the fourth voltage or voltage across the fourth branch? Again, it is 6.25 is that particular voltage. Means here, in this particular case, we have copied this VB. We have copied this VB. This is YB we have taken from the previous points, and this is VB plus IS. IS is the current source matrix. Here already we have calculated this IS plus this IS, and IS is, it is minus 10, this is 0, this is 0, and this is minus 5, and this is the matrix IS. Now with these points we can find out the values of the currents. I will start with the calculation of the I1. This I1 is equal to first row, this column, plus or minus this value. This is 1 into 8.75. This is 8.75. This is 8.75. Plus the 0 into that value means it is plus 0. The 0 into this value means plus it is 0. 0 into this value means plus it is 0. And then plus this minus 10 means, to be exact, it is minus 10. This is equal to, it is 8.75 minus 10 is the current in that particular branch. Means here, if I am doing the calculation, it is 8.75 minus 10. This value means it is minus 1.25 amperes is the current in the first branch. It is minus 1.25 amperes is the current in that particular branch. If we know the value of the first current, that is I1, similarly, we are interested in the calculation of the current I2. How is I2? This second row, this column. Means 0 into this 8.75 will be 0. 0.5 into that plus. This is 0.5 into that minus 2.5. This is minus 2.5. That calculation. Plus 0 into 6.5 will be 0. Then the 0 into 6.5 will be 0. Again this plus 0. This is plus 0. This is equal to only this value, that is 0.5 into minus 2.5. This is 0.5 into it is minus 2.5. In that case its value will be minus 1.25. This value is again minus 1.25 amperes is the value of the current I2. If we are calculating the third current, which is I3 in this case, which is equal to this third row and first column, 0 into that's 8.75 will be 0. The second will be 0. The second value will be 0. Third value is 0.5 into, this is plus, this is 0.5 into 6.25. This is 6.25 plus this 0 into 6.25 will be 0 plus this value which is nothing but 0, which is equal to. If I am doing this complete calculation, it is a 6.25 into 0.5. Means it is 6.25 into 0.5. If we are doing this calculation, 3.125. Here in this case this I3 is 3.125 amperes is that current which is I3. Finally, if we will calculate this I4 is equal to this last row into this column, 0 into that 8.75 will be 0, the 0 into that 2.5, that is minus 2.5 will be 0, then the 0 into 6.25 will be 0 plus this 0.5 into 6.25, this is 0.5 into this value 6.25 is that value plus this value or plus minus 5 means actually it is minus 5 which is equal to. I will work out this calculation. 6.25, this is 6.25 into 0.5, already we have answer with us which is 3.125. I will just subtract 5 from that, minus 0.5 means it is minus 1.875, is minus 1.875 amperes is the current flowing through that particular branch. Means in this case, this is the approach for the calculation of the branch currents. Now look at how is this procedure. In this case, we have calculated the branch currents. Current in the first branch, current in the second branch and current in the third branch. And if I am going to the original figure, in this case, this is the original figure. This current I1 is minus 1.25, this current I2 is minus 1.25, again this current I3 is at 3.125 and the current in the fourth branch, this current is nothing but minus, it is 1.875 amperes. This is minus 1.875 amperes. This is the way of calculation of the currents by using this particular method. I will reorganize everything and just within a minute I will discuss what are the steps needed for the calculation of current using this approach. If I am going into this calculation in detail, look at calculate the current in this particular case by using this particular approach, that is reduced incidence matrix method. First step is creation of the oriented graph. First we have to bring the figure into the standard format which is required for this reduced incidence matrix. Means every branch impedance should be represented in terms of the admittance, and every voltage source is represented by the current source. Means all branches should have the values in terms of the admittances and all voltage sources must be represented in terms of the current sources. From this figure we will prepare the second point is nothing but the oriented graph. From this oriented graph we will prepare the reduced incidence matrix. We will prepare the branch admittance matrix. After the preparation of the branch admittance matrix we will prepare YN, that is node admittance matrix, that is YN. This node admittance matrix is calculated by using the expression A into YB into A transpose. This is A into YB and A transpose we have carried out and we are in a position to find out the YN. After the calculation of YN, we will find out the IS, that is current source matrix. And then we will find out this node voltages by using this relation YN into VN, which is equal to minus A into IS, where YN is the node admittance matrix. Vn is the node voltages, then A is the reduced incidence matrix, and Is is the current source matrix. I have substituted the values. This is Yn, this is Vn, this is A and Is. If we are doing the simplification, we are able to find out the node voltages or node potentials, which is nothing but Vx and Vy. If we know the node voltages or node potentials, we can find out the branch voltages. We can find out the branch voltages. What is the equation? Vb is equal to A transpose into Vn. This is A transpose and this is Vn is nothing but the node voltage matrix, which is Vx and Vy. This is the value of Vx and this is Vy, and using this relation we are able to find out the branch voltages, which is V1, V2, V3 and V4. And finally we can find out the branch currents by using expression. This IB is equal to, that is YB into VB plus IS. This YB is nothing but branch admittance matrix, VB is nothing but branch voltage matrix, plus this IS is nothing but current source matrix. If we will substitute all these values and if we will do the calculation, we are in a position to find out its value of the branch currents. This is the way of this calculation by using the reduced incidence method. That's all about this particular lecture. Thank you.